Okay, let's get started today. Today we're going to be focusing on particle effects, and then we're also going to talk a little bit about Lab 1. And let's go ahead and get started. We have a little bit of stuff to cover today, and I'm going to do some programming with you today as well. So to get started on the stuff today, we're going to deal with particle effects to start with. And we've already done this a little bit, as we'll see here in a second. So let's go ahead and get started. All right, first off, particle effects are used in a lot of different games and movies, films, all over the place. But they're basically used to simulate and render some sort of fuzzy phenomena that would otherwise be difficult to produce. So they work well for systems or situations that have a lot of different entities that are independent from one another, but they combine to create whatever that overall effect is. And those types of systems can be widely varied, and they can add a lot to your game, not just from the visual experience of that, but also from the mechanics experience of that. So they can visually be very stunning, make something look very rich, but they can also add mechanics elements to the games as well. Now, some examples of things that particle effects work well with will be things like sparks, snow, dust, smoke, fire explosions, water like rain falling, leaves blowing around in the wind, mist and fog. So a lot of things like that. So as an example, if we wanted to make a game that had like a snow effect, as is going on outside right now, I don't know if you can see that in the thing, but there's like snow falling and it's kind of making this really kind of hazy view of things, and you can kind of see the individual elements falling. Can't tell if you can see that or not, but that is kind of the kind of effect that you could get in a game that would be hard to hand program all the individual snow things, but particle effects handle something like that really well. It's also lends itself well to organic effects, like things like fire that are kind of changing or something that's on fire. You don't want it to look like a pre-recorded loop. You want it to look organic and changing, and when the person runs, it leaves a smoke trail or behind or whatever. But those are the kinds of things that particle effects really help with. Now, all of those things, if you think about what they have in common, they all have independent elements that combine to form the overall effect. So sparks, they're individual sparks flying off something. Snow, individual snowflakes. Dust might be individual specks of dust or individual like blobs of cloud, parts of the clouds for that. Same thing with smoke, same thing with fire. It's kind of got this organic changing thing that's layered on top of itself. As something's burning, explosions, something blows up and pieces of it go other places. There might be a fire associated with that. Water, obviously, the raindrops are all individual, but they could combine and form something larger, but that still moves over itself. And there are other ways of processing flowing water as well, besides particle effects, things that use like blobs, which we're not going to talk about today. But then leaves blowing, obviously, individual leaves, the wind blows, there's a swirl of dust and leaves, mist and fog, same kind of concept as dust and smoke. Now, they also, all those effects can also be combined. And notice I also added embers here. You get a fire that has the burning part, but also embers coming off of it and smoke. So these things could be combined. And a good example of that might be that you have something burning that's making sparks, that has fire layered on that, and smoke coming off of it, and embers that are kind of drifting up away from it. So layering all those things together can create these really remarkable, stunning visual effects that can add a lot to the environment. And here's an example of that from a AAA title. And you'll notice there's this fire burning, and that in the game, it's kind of looks very organic and real, but there are these kind of glowing embers of ash that are kind of flying up away, some of which are on fire, but then they turn darker as they get away from the fire, floating around. And that's the kind of thing that you would see with particle effects being really useful for that. Organic effect layered on top of itself in a way that looks organic and looks realistic and is kind of changing. Now, particle effects can also be used for making abstract visual effects. So rather than something realistic like fire or snow or rain, you can also use it for kind of magical looking things, motion blur, glowing trails that things leave behind. You cast a magic spell and you wave your wand and it leaves sparks behind it, or your little fairy creature with wings as it flies around, leaves little sparkles behind it in the air or whatever. But and here's an example from a game. This is a Candy Crush screenshot, but you see these little sparkle things that are kind of happening when you blow things up, and also the kind of motion blur with these vertical lines and horizontal lines from these as they explode sideways and up and down. Those things can all be done with some form of particle effects, and it adds a whole lot to the game experience. It has a whole lot of kind of visual effects that trigger the reward centers in people's brains. There's a reason why Candy Crush has made so much money, and that's because when you blow those things up and they fall down and the effects happen and stuff collapses and chain reactions happen, that people find that very stimulating. And so those kinds of more abstract and not realistic things like burning fire or snow and rain can also be very rewarding. And you can mix the two. You could have a game where the dragon breathes realistic fire, but the wizard casts a spell and it leaves magic sparkles and blue sparks in the air or whatever. So you can also use particle effects to have disorienting effects with like fog and smoke. And even in 2D games, for example, there's a game called Heave Ho, where it's got these little characters that have to like work together and join hands to get to the goal position on the screen. And in that game, there's a camel that walks by, and for, I guess, to be polite, it passes gas and makes a giant cloud that then makes it more difficult to get to your goal. But that is all done with particle effects, and those things can be really part of the game mechanics, part of the game environment, but also visually interesting or even stunning in some cases to work with. All right, so to start off here, let's talk about the concept of a particle system. So a particle system can be thought of as a group of independent but related particles. So every particle has some position. If you're in a 2D game world, it'll have an X and a Y. If it's 3D, you'd have X, Y, and Z. But it also has a motion vector. In other words, how is it traveling? Where is it heading to, and at what speed is it heading there? Also, most particles in particle systems have some sort of a lifetime associated with them. In other words, that lifetime might be, in the case of like a snowflake, until it hits the ground. But in the game worlds, a lot of time you have things where they have a certain lifetime where they expire after a while and new ones get created. So in other words, as smoke goes up away from its source, it might get larger and more transparent until eventually it's removed. So we're not wasting memory on it and taking it up if it's having minimal impact. So that lifetime can be important. That's how long it's going to stay alive before it gets reclaimed or goes away. There might also be color variation over the lifetime. There also might be a size variation over the lifetime. And really, you could change a lot of things over its lifetime. You could change its speed over the lifetime. They could get slower, so they move fast and then slow down. Like, for example, for fireworks effects, it also could change how it moves over its lifetime. It could move in a straight line, but then become more squiggly toward the end. But anyway, this lifetime is can be used for more than just reclaiming the particles once they're done. It can be used linked to modifying other parameters or other parts of the behavior of those particles. Now, one of the things to note is that it's common for those at least initial values to be chosen somewhat randomly or within specified bounds. So in other words, the speed and direction of a created particle, we don't want them all to be the same when they're created. You might have some randomness to it. So, for example, an explosion, things will go in random directions. Or maybe if it's something that's shooting out like a water hose, shooting out a stream of water, there'll be some randomness that kind of wiggles around and adds some randomness to it. So it's not like a straight line. It's more of a realistic burbling hose effect to that. You might also have some variations in the color, variations in size, variations in what happens and how quickly they change those things over a lifetime. But adding that fuzziness to it, the ability to have a little bit of randomness to that within some bounds, can give you that organic effect. Like a fire, you don't want to walk through your dungeon and have every flickering fire look exactly the same as every other one. You want to have some randomness to it. You might have it that when the wind blows, and the leaves blow down the alley, the fires kind of are affected by that as well, and flicker in the flame flickers in the wind that comes through. All of those things are possible with particle systems. Now, one other concept we have is the concept of a particle emitter. And what a particle emitter is basically the thing that produces the particle entity. So in other words, it's something producing it. So you imagine like a burning fuse. It's going to be producing these little sparks from that thing. So it's emitting or creating the little particles. Or you might think of like a bomb exploding as creating the shrapnel upon it exploding. And so a particle emitter can be thought of as creating particles and adding them to that particle system or that particle list. Emitters themselves can also be objects that have their own 2D position or 3D position in space, and they could also have a velocity and a lifetime, and they could change their behavior over time as well. So in other words, if you have like a sparkler, and it's creating sparks, and it's also creating some smoke, you can move that sparkler around, and it's still going to leave behind a smoke trail, and it's going to leave behind the sparks as you move it around. So also those emitters will often define the initial particle conditions, and that could be based on lifetime. Like as the sparkler is operated and it reaches the end of its lifetime, it kind of might fade out and produce fewer sparks until it stops altogether. Or it could be, if it was a fuse, it could create little sparks until it gets to the object, and there could be an explosion when it gets to the end. And that's kind of what you're going to do in the lab that you're going to do later today. All right, so particles, particle emitters, particle systems are obviously related. So the entire method could be separated into kind of these distinct phases. The emission phase, where something is creating these particles, and they're created according to some emission rates, some initial parameter values and ranges. Then we might also have the kind of update and simulation phase, where once after they've already been created, we have to update them. So in other words, the sparks change position. They might change their speed. They might change their size. And we also modify the lifetime as we go through that. And the last phase of that is rendering them. Now we have this collection of these things. We need to draw them on the screen, given their size and their position and their whatever visual effect is they've changed because of their lifetime. But those three phases, you create them. Once they're created, we update them, their new positions, and then we draw all of them. And we've done something similar to this before. We'll talk about that in a second. But the last part of this phase is obviously getting rid of them, reclaiming them. So when their lifetime is expired, we take them out. They're gone. They're gone from the system at that point. Now, implementing particle systems, how do we write the code for this? It actually turns out that it's pretty easy. We have done this in previous labs. That if you think about those bullet examples from the previous labs where we created a list of bullets or a list of balls, and then we updated all of them in the list, moved their positions, and then we drew all of them in the list to show them on the screen, and then we repeated that over and over again. That list of balls or bullets or whatever we wanted to think of it as, being updated and rendered, that's a lot like what we were talking about with these particle systems. So if we think about those bullets in that bullet list or the balls in the ball list, then each one had a position, meaning an X and a Y, an angle of travel, a velocity that it was moving at, which is the same as the speed. So just like particles. But also that list kept track of all of the active ones, which made that kind of like a particle system. So a list of particles is a particle system. And then the thing that's maintaining that list and saying, here's where the particles are getting created and added to that list, that's like the emitter. So the emitter, you can think of the emitter having a list inside of it, a position and a list inside of it. That list then has particles inside of that. And as we move the emitter around, the particles where they're being created will move with it. And so we've kind of done this code before. So let's look at one more thing before we actually dig into writing some code for tonight. And that one more thing that I want to take a look at is a part of Pygame that maybe you've been exposed to, maybe you haven't, but there's a special thing in Pygame called GFX Draw. And what GFX Draw is, it's a set of drawing functions that are kind of alternatives to the pygame.draw.circle, pygame.draw.line, and so forth. But they have a special submodule called GFX-Draw, and the functions in GFX-Draw offer us one particularly useful advantage over the normal drawing functions, and that is they support an alpha channel or a transparency value. So, for example, pygame.gfxdraw.field_circle, you pass it a surface, you pass it an X, you pass it a Y, you pass it a radius, you pass it a color, but the color parameter in this can have not just red, green, blue, so not just like 255, 255, 255, but there's a fourth element we are allowed to add to that tuple that gives us the alpha value. And what the alpha value is the transparency level. So in other words, it ranges, it's a byte just like the other ones, but so it ranges of the value 0 all the way up to 255. 255 is completely solid. 0 is completely transparent. So if you put 0 here, you won't be able to see it. If you put 255, it'll look like a solid circle. But if I put something like 127, that'll be about halfway transparent. If I put something lower than 127, like, I don't know, like maybe 50, it'll be pretty transparent. You'll still be able to see it, but it'll be pretty much, you can see through it. And if you put something at like 200, it'll be just mostly solid, but you can see through it just a little bit. But this ability to do this, have this alpha channel, can be particularly useful for particle effects. Like imagine smoke, where as the smoke cloud grows, you want to be able to see through that smoke to see what's behind it. Or you might think of it as even sparks. They make like a glowing trail as they move, but you can kind of see through that glowing trail. So alpha channel, particularly useful for particle effects, and we're going to look at using that. Okay, so what we're going to do now is we're going to write some particle effects example code. We're going to start with a simple particle class. We're going to get some code working with that. We're going to then make a particle system out of it with another class. It's like particle system class is like a list of particles. Particle class is a single particle. And then from that, we're going to play around with adding some gravity to it, making it so that particles change color and size over time. And then we're going to move on and make a particle emitter class that we can then move the particle emitter around. And it internally will have a particle system inside of it, which in turn will have particles inside of that. All right, so let's go ahead and get to writing some code. So, let me leave that there for a second. I'm going to pause the video and get Python up and running and ready to go. And then we're going to live code some stuff. So if you want to follow along, you can pause the video here. When I pause the video and get set up to follow along on in Python or on another screen or however you want to do that. If you want to wait till later, feel free to wait till later and then try to implement what we did today as well. But the idea here is we're going to go ahead and start writing some code. And I want to put together some examples that do this stuff so you can do that. And then we're going to talk briefly about Lab 1. So let's go ahead and pause here, get set up to code along with me, or just follow along and then try to do it later. But I'm going to pause for just a second. Give me a break here for 10 seconds, and I'll be right back. Okay, so we're back. And what we're going to do initially here is we're going to essentially look at creating this simple particle class. Let me switch over so you can see what I'm programming here. Okay, so this is going to be our first example here, and it says simple particle class. So what we're going to do is we're just going to write some code. We're going to throw some code together here to make this happen. And the starting point for this is essentially going to be creating the base particle class to keep track of one particle. So let's go ahead and get started with that. So first off, I'm going to use Pygame. Just like before, we're probably going to need some random numbers. So I'm going to import random. And I'm also probably going to want to do some trig. So we're going to import math. And just like in all our other things, I'm going to say pygame.init to initialize it. I'm going to make my display surface ds equal pygame.display.setMode. And you should be getting familiar with these things. And now let's make our game loop. So while true. What do we want to do? Let's get the keys. Well, let's do pygame.event.pump. And let's get the keys. Keys equal pygame.key.get pressed. And then we'll say if keys pygame.k_escape. So if they press the escape key, we'll break out of the loop. At the bottom of the loop, we'll do pygame.display.update. And then after this, we'll close the window, pygame.display.quit. All right, so we've seen this code before. There's nothing new here. Basically, just get pygame set up, pull up the window, and have our game loop. Once they hit escape, we close the window, and once that window closes, or once they were out of that loop, then we hit that pygame.display.quit, which closes the window, and we're done. And usually I'll go, as I'm developing this, I'll go ahead and test this. Let me call this particles1.py. And there's our window. Nothing happens. We hit escape. It closes. All right, so we're all good. Now we're ready to actually start writing our particle class here. And for our particle class, what I want to do is basically create a class for a particle. So up here at the top, I'm going to go do that, class particle. And just like with other classes, we're going to have a constructor, so __ init, and self. Now, for these particles, we want to be able to specify where it starts on the screen, what its initial direction is, what its initial speed is, and what its essentially what its initial lifetime is. And by us doing that, that's going to allow us, we also might want to specify the start size, the start color. There's a whole bunch of things there that we might want to specify when we create these things. So I'm just going to list those here in my constructor. So here I'm going to call this, let's say, start x. So that's the starting x point, the starting y point, start direction, or we could call this angle. Maybe start speed. Now you could store the velocity vector there, vx, vy, whatever you want to, however you want to store that. I'm going to store it as angle and speed for right now, because that matches up with what we did with the ball last time. And now let's say start lifetime. That's how long it's going to exist or continue to exist. And then I might also have a start size. So how big is it when it starts? And then we might also have here like a starting color. All right, so there's a lot of things that I added to that list. And what I'm going to do here is I'm basically just going to turn those into attributes. So every one of those things there, I'm just going to turn that into an attribute for this thing. So all of these things here, I'm just going to paste that in there. And I'm going to say self.x equal whatever the starting x is. Self.y equal whatever the starting y is. Self.angle is equal to whatever we specify the angle to be. Now you don't have to put start underscore in front of all those. You could have just put, I could have done that without that. And if I were writing this code, I probably would. But I want it to be clear to you, those are just the initial values, not what they will necessarily have the entire time the thing is in existence. Okay, so we have effectively just made attributes out of all of those individual things. And we haven't really done much other than that. Right now, this only has attributes that get created. So now, as we talked about before, we kind of have those two things that we can do with a particle. We can update the position of it, and we can render it. So let's add the code for that. So def, let's call this one update. And update here, you might pass in a DT, how much time has passed, and use that as part of the thing. But if we set a fixed frame rate, we could get by with it just saying update the particle and have it just assume what the frame rate is. And that's what we're going to end up doing for this. But if I were writing this for a commercial application, I'd probably build like a DT into that. You pass in a DT for update, and it uses how much time has passed to know how far things have moved and so forth. And we'll talk more about that later on in the semester. But essentially, to move this thing, we just need to compute the dx. So dx equal self.speed times math dot, now this is x, so this is left or right, so cosine, math dot gradients of self dot angle. All right, so we've done this math before multiple times. So that's my dx value. And I also need to compute dy, which is going to look just like dx, except this is going to be sine instead of cosine. This is going to be dy. And because the coordinates are inverted, -1 times that. All right, so there's the dx and dy. Now we need to update the position of that object. So in this case, I'm just going to say self.x plus equal dx, self.y plus equal dy. All right, so pretty simple. And there's one other thing I'm going to do here, and that's I'm going to reduce the lifetime by, and I'm going to use an integer lifetime. If you wanted, you could have the lifetime be in actual seconds, and then reduce it by the dt, how much time has passed since the last time through. But to keep this simple for right now, I'm just going to say self.lifetime minus equal 1. So in other words, we subtract 1 from it. So in other words, if I say, hey, this thing is 200 frames worth of lifetime, every frame that it gets drawn, it'll get 1 subtracted from it, and eventually it'll reach 0. Now, that's it for right now for what we're going to do with update. Let's do, and we can change this stuff later, but let's do render. So render. And when we go to render this, basically that's just going to be what draws it on the screen. So here I'm just going to do a circle. And I'm going to go ahead and, actually let's go ahead and use GFX draw now. So one thing we need to do if we're going to use that, I need to import that so separately. And then down here, to use it, pygame.gfxdraw dot, and that's actually a filled circle. And remember the way that the filled circle worked, essentially we give it the display surface, which in our case is ds. We give it an x, which is going to be self.x. We give it a y, self.y. We give it a radius, which I'm just going to use self.size. And we give it a color. Now, here's where the color comes in. The color can include a transparency, but for right now, I'm just going to say self.color. And since the color isn't changing or anything like that. Now, one other thing we might want to do here is only draw that if the lifetime is greater than 0. But eventually what we're going to do is we're going to reclaim particles that have expired. So right now, let's go ahead and add that. And we could actually even draw these in a different way. So I'm going to say if self.lifetime is greater than 0, then we draw it. But we could leave this off because we're going to take them away when they're done, and they'll never get drawn when the lifetime is less than or equal to 0 anyway. But for now, let's just put that on there. Okay, now let's write our code that actually does something to create those things. And so for this first example, what I'm going to do, rather than creating a particle system object out of these, I'm just going to make a list. We're just going to do this as a more brute force way here. So I'm going to say particle list equal, it's going to start out empty. All right, so relatively simple. We've done this before with the bullet list and the other things. And now the next thing that I'm going to do is I'm going to then have it so that if they press a key, I'm going to add particles to that particle list. And we've done this before as well. So here I'm going to say if keys pygame, let's do space. Then let's add a particle to the particle list. So particle list dot append a particle. And for a particle, remember that class we had up here, it needs all of these different things in order for it to be created. So we're going to add all of those down here. And what I'm going to do is I'm going to break these out into separate things so you can actually see how this is created rather than putting them all in one long line. So we just need to come up with these things here. So what I'm going to do is show how we're going to fill in each of these things when we create it. And here I'm going to go ahead and use these same variables that we had down here. And actually, let's make it a little simple. Let's just put P in front of each of these. So particles X, the particle Y, the particle angle, and that should keep it so it's easy to tell this is different variables than those other ones inside of the class. The lifetime, the size, and the color. And we're going to pass those into that function. But first, let's give them values. So let's create it when they press space. Let's always create this at 400, 300. Let's set the angle equal to a random dot rand in 359. Let's set the speed random dot uniform 0.1 to 2.0. Let's set the lifetime equal to, now this is going to be in frames, and we're going to bound the frame rate. So let's set them all to right now. So they'll all last for 1 second, at least for right now. And then let's set the size here. Let's just set that always equal to 5. And the color, let's set that just to white for right now. So now when we go to create this particle down here, we're just going to plug all those things in. So Px, Py, P angle, P speed, P lifetime, particle size, and particle color. All right, so that's appending that particle to our particle list. And notice we can change how we create those initial particles, change the position where they're created, change the angle range, the speed, the lifetime, and so forth. But every time I press the space bar through the loop, I'm going to get that. Now let's go ahead and limit the frame rate to 120 here. So let's do FPS clock equal pygame.time.clock. So we make that clock object, and then up here, FPS clock.tick, 120 hertz. Okay, so that does that. Now what we're going to do inside of my main code down here is I'm just going to make a for loop and say for particle in particle list. What are we going to do? We're going to update it. So particle.update and particle.render. Now notice right now I don't have anything that's reclaiming the lost particles or the ones that we're done with. We'll deal with that a little bit later on. But let's go ahead and run this, see what happens. Hopefully I didn't make any terrible mistakes, but let's just see what happens here. And I did. Okay, this is the stupid thing where it requires floats for those, or ints for those instead of floats. So let me fix that. So I really wish they would just put that into the library. So here I just need an int on x, int on y, and int on size. Just in case, right now it can't be anything other than an int, but okay, so here's my code. I press space bar. Notice those particles come out and they eventually disappear. Now, right now, it's leaving behind this thing that looks like an ink splat. The reason being, I'm not erasing anything. So let's add our erase to our main loop here. So up here, let's do an erase. So that'd be display surface.fill. Let's fill it with zeros. So black. And now let's go here. And now I press the space bar. Particles come out of that center position. And notice they live for a certain amount of lifetime and then they disappear. Now we're not reclaiming them. They're still in our list, which is bad. And that's the kind of thing that creates what's called a memory leak, that even though we're not drawing them, they are still in existence in that list. So we need to add some code to reclaim the ones that have died. And to show that those aren't really dying, or not really disappearing, okay, let's go back up to our object up here. I could add an else here. Say else. And I could just say, hey, when these are dead, I'll still draw them. But I'm going to draw them a little bit differently here. Oops. Here, I'll make them no longer filled. And then you can see that they're still there. They're still in the list. They're just not being drawn anymore. Which is kind of its own little nifty effect there, that they eventually disappear. But we want to reclaim them when they're done. All right, so let's fix that code to reclaim them when we're done. All right, so I'm going to go and take this else out, since we're going to now reclaim them. Now, how do I reclaim them? Well, what I need to do is, as I'm going through the list, I'm going to keep track of any of them that have, after they've been updated, their lifetime indicates that they need to be removed. So I'm going to say particles to remove list. I'm going to make that a list. Here, I'll even call it list. And then what I'm going to do is, after update, I'm going to say if that particle dot lifetime ever gets to be less than or equal to 0, particles to remove list dot append that particle to that list. So in other words, I'm saying, hey, if I've updated one and its lifetime has gotten to be less than or equal to 0, then I'm going to add it to this other list, and then I'm going to remove it later. And then after I'm done with this loop, I'm going to say for particle in particles to remove list. So I'm going to go through every one that's been earmarked for removal, and I'm going to remove it from my actual particle list. So particle list dot remove particle. So now let's see what happens. And now I can make those, and they will disappear from the list. And now they're no longer consuming memory. Now, if I want a little bit more aggressive effect with those particles being created, rather than kind of slowly like that, which looks a little bit, you can think of that kind of like sparks. Notice if I want them to be created differently or moved differently, I can really just come in here and change these things. So for example, if I want this to be partly transparent, I can put 100 there. And now you'll notice them kind of fading out as they age. I guess they're not fading out, they're just layered on top of each other. We could make it so they fade out as they age. But notice that gives a little different effect. And if I want a lot more particles to be created, then what I could do is, rather than when they press space just making 1, I can put this in a for loop, because it's for I in range 10. So every time the space bar is pressed, we're going to get 10 particles created. And now we have something that looks quite a bit different, a little bit different effect. Let me move that way you can see it a little better. Okay. Oops. That's not where I wanted to go. And if we want to keep the size, or keep them not transparent, we can just do that. And notice we could also do some interesting things here as well. Notice that there's a lot of how they behave and what they look like are dependent on these initial conditions here. So the angle, I could make it more like a fountain that sprang up. I could change the speeds so that these are from, let's do 2.0 to 5.0. I can make the size here be smaller. I can make the color different. Let's make this range so it goes from, let's do 80 to 100. So it's like this 20-degree range at the top. Let's press that. And now notice we get kind of more like this fountain effect. So it's a totally different effect that we're getting now than we got before. Or if we want to aim it sideways and make it look more like a water cannon spraying water, we could go from, instead of 80, we could go from -10 to +10. And I could say, let's keep the speed like that, but let's make the color of it blue. So let's do 0, or let's do 100, 100, 255. And let's make these slightly transparent. Let's do 150 there. And so now we have this kind of jet of, looks more like a spray, I guess, than anything else, but we're spraying that out to the side. But eventually they're all getting reclaimed and disappearing. And you'll notice already that we're getting different effects. One that looks like a fountain going up, one that looks kind of like a spray nozzle going to the side, one that looks like an explosion with things going out away from that center. And if we continue down that kind of road, you'll note that we could do all kinds of things with this. We want it to be really transparent. I don't know if you'll even be able to see this. Here, let's go to 50 maybe. It looks even more wispy as it gets away from that center point. But you get a different effect from that. Okay, so that's where we are now. So again, if you want to take a little break here, now's a good time to do that. Not a lot of code, and you'll notice it has a lot in common with the stuff we did previously with the balls moving and other things. But the next thing that I want to add to this from where we are now is I want to turn this into, rather than just being a particle, single particle class, I want to make a particle system class out of it. And rather than having all of this code like we have down here in our main that's moving the particles and doing that, I'm going to move that into that particle system class. And it's going to seem really familiar. It's going to do something like we saw before. So what I'm going to do is basically create another class and build it on that one and do what I did in the code down there. So here, class. Or here, before I do anything else, let me do a save as on this and change the name here. Simple particle class with particle system class. All right, let me do a save as. And let's call this particles 2. Electric boogaloo. Okay, so now we're ready to create our particle system. So up here, class, particle system. Works the same way as every other class. Our constructor. And in our constructor for this particle system class here, I'm really not going to pass anything else into that right now. I am, however, going to, that's where I'm going to put this particle list. So in here, I'm just going to indent what we already had underneath that and put a self in front of it. So this is going to become part of this thing. So self dot particle list. Now, the next thing that I'm going to do here is I'm going to say, I'm going to make another thing for emitting those particles. So here, I'm going to say emit particle self. And here, I'm going to list all of those things that we had up here, because that's part of what we want when we create those particles. So I'm going to put all that on the end of that. All right, so that's pretty easy. But then what I'm going to do inside of here I'm just going to add a particle to my particle list that has those attributes. And we actually did all that down here. So right there, I'm just going to do a copy on that. And I'm going to paste it all in right there. And I'm going to align the indentation levels a little better here. It's one thing about Python we have to make sure we get. But here, rather than particle list.append, I'm going to say self.particle list.append that particle with all those things. And then here, rather than, I guess, start X, start Y, and all of that stuff, I suppose we don't really want all of this stuff in here. Let's just, here, let's take all of these out for right now. We'll come back to this in a second. But we're adding that particle. Let's make these PX, PY. Or here, we can just put start here. So let me, I'll just put the word start in front of these. So we're basically just passing those things through from the emit particle method to the creation of that object that then is subsequently being stored in the list. All right, so that's pretty straightforward with creating that. And then the other thing that we're going to want to do here is I'm going to make a function for moving all the particles. So move, or let's say update particles. So that's going to update all of them. And then here, I'm also going to make a thing for render particles. Okay, so we have those two things there. We already have code that does something similar to that down here. So I'm just going to take this code for right now. I'm just going to cut it. I'm going to come up here. And for updating, that's the part that's moving them. So that's going to be called the update on all of them. If the lifetime is there, we'll do that. I'm just going to take this particle render out of here right now. So there's my update. So the update is responsible for moving them and getting rid of any that we don't need anymore. One thing I do need to do here, though, is I need to put self dot in front of this. And then down here, I'm going to do another loop that goes through each particle, but rather than updating it, I'm going to render it. All right, so it's the same stuff we've done before. The only difference here is we're now storing that inside of the particle system class rather than storing it inside of my main code down here. So that means to actually make this code work down here, what I'm going to do is I'm just going to make one of these emitter objects. So I'm going to say particle emitter 1 equal, and let's just call it emitter 1. Or not, let's not call it emitter, let's call it system 1. Particle system 1 equal, and we're going to make one of these particle system classes here. So particle system 1, we're going to make that a particle system. And then in my code down here, when I press spacebar, I'm going to do particle system 1 dot emit particle. And then remember, we just pass all of these things through. So I'm just going to reuse that code. So I'm going to cut this out, still generate that PX, PY, all of this other stuff. But here, rather than doing a list.append, I'm going to do particle system.emit particle. Put all of those things in there for how we want it emitted. It's the same kind of thing we did before. We just kind of rearranged things a little bit. And now in my main program, all I have to do is do particle system 1 dot update. particle system 1 dot render. So notice how simple the main part of the loop is down here now. Let's run that and make sure I didn't screw it up. And I apparently did invalid syntax here. I'm probably missing a parenthesis. Oh, I'm missing a colon. Particle system has no update. Oh, I think I call, oh, I'm on the wrong thing. I think I call it update particles. Yeah, update particles and render particles. So what I need to do down here is we'll just change the name of this. We could have called it update and render. All right, let's try that. Particle reference before assignment. All right, let me look at what line that was on. If particle.lifetime is less than or equal to 0 in line 37. So let's go back to that code and take a look at that. Line 37 is down here. Oh, this needs to be indented underneath there. All right. Cut and paste error. And now when I press the space bar, you see same effect we had before. But the cool thing about this is because we have that as an emitter, as a particle system, that we can now make multiple particle system objects and tie them to different things. Like say when I press the F key, I get one behavior. When I press the G key, I get a different behavior. And let's do that, and then we'll take another little break here. So let me go back to that code. So we're going to make two particle systems now. Particle system 1, particle system 2. And particle system 1, when it's getting created down here, that's happening with space. I could down here, let's make these angle upwards. So let's go back to that 80 to 100, positive 80 to 100. So that's adding things to particle system 1. Let's add another kind of particle instead of space. Let's add another one to K underscore, I don't know, let's do the S key. Or let's do the A key. If I press the A key, then let's make these work a little differently. Rather than 400, 300, let's do this as 200, 300. Let's do 200, 400. This one at 400, 400. And now the angle of spread on this one, let's make this a little wider. So let's do 75 to 105. So a little bit wider. Let's make the speed a little bit different. Let's go 3.0 to 6.0, so a little bit faster. Let's make the lifetime a little shorter. Let's make the lifetime longer. Let's do 200 instead of 120. Let's make the size, let's make a randomness to that, so random. So let's go between 2 and 5. And then let's make the color of these ones kind of more of a cyan, or let's make them yellow. Red, green, a little bit less blue. And let's make these a little more solid. So this is going to become particle system 2. And then down in my main, I'm going to update particle system 2's particles and render all particle system 2's particles. And what we're going to see is there's me pressing space, and I get that fountain. and I press A, I get a different kind of fountain. So notice those have a different effect. One of them is they're moving faster and there's a range of sizes. One of them is blue, but we can do both of them at the same time. So now we have two different particle systems that we can manage, one that makes blue things, one that makes yellow things. And if we want, we could take that yellow one and we could change it so rather than spraying upward, we can make that one spray any direction. So 0 to 359. So now I have one that sprays up and one that kind of sprays garbage out. And if we want to slow down the emission rate of that, make it go a little bit slower, notice that's really easy to do. We just make fewer of these. Let's make 3 every time instead of 10. So notice we're getting two completely different effects. One from the yellow stuff, one from that. And in fact, if we wanted to, we could make something that works a little more like snow drifting down from the top. We can make something that looks, so the emitter, rather than being at a point like we have here, it could be all along this top edge. It could be anywhere along the top edge and the things could drift downward. All right, so let's go ahead and pause there again. And then the last thing I want to do today is add in something where the colors change over time, and we put in an emitter that we can move the emitter object around. An emitter really is just another object wrapper that's going to wrap around a particle system of a certain type. And we're going to make a couple different types of emitter. But before I do that, I want to add gravity to this. So the particles that come out, they'll kind of fall downward toward the bottom rather than just going the direction they're going. And we're going to use that by doing that stuff to add forces that we looked at last time. So go ahead and pause it there. We'll come back and we're going to add downward gravity to these, which means that we're going to we just have to change the update of this by adding in that extra vector. So we're going to do that. And then after we add that gravity, I'm going to make them so we can change the size and color of those things over time in some way, which should be where we'll finish up today with that, and then we'll talk about your lab. So go ahead and pause again right there, and we'll be back in just a second. If you want to take a little break, get a little drink, feel free to do that, and we'll resume in a second by adding gravity, and then we're going to have that emitter that we can move around for each of those two things, and then we'll talk about lab 1. So let's go ahead and stop there for just Okay, well, we've been going on for a while today, so I want to quickly just add that gravity to this, and then talk about making this an emitter, these things emitter classes. And in order to do that, let's just go ahead and start and add the gravity. So to add gravity to these things, since both of these are created from this same particle class, I'm just going to go ahead and quickly add some code in here to make this have gravity. And if you remember, the way we add gravity is we're adding that force in the downward direction. So I'm just going to add a little comment in here in the update for this. Add a downward force. So to add a force, I'm basically going to say take that the dy that I computed and add a little more to it. So dy is how it's changing up and down. So we're going to add a little more change in the downward direction. So I'm going to say dy, I'm going to say plus equal. And when I do a plus equal, I'm just going to add a little bit. And we could play with this value later on. I'm going to say 0.5 for now. So we're adding a little tiny bit of force in that downward direction. But notice it's going to happen every time this frame gets updated. And since I changed dy now, I need to convert that back into a new angle and a new speed. So to do that, self.speed. And if you remember how we did that, that's just Pythagorean theorem. So dx squared plus dy squared raised to the 0.5. So the square root of dx squared plus dy squared, that gives us our speed. And if you remember how we compute backwards to get the angle, that's just going to use arctangent 2. And this is what do we call it, angle? So self.angle equal math.degrees of math.arctangent2 of negative dy comma dx. And we've done that before, so that converts backwards to get a new speed and angle, and the next time through the loop, it'll have a different speed and angle. All right, so really that's all we really need to do. The other stuff still should work the same, so those 3 lines of code should now add some gravitation to this. So let's go ahead and press the space bar. And you'll notice it's quite a bit of gravitation, but notice that fountain now is pulling those things down. When I press A, those things are all getting pulled down as well. So maybe the gravitation is a little bit high, so let's and I don't know how well you can see that. Let me make the transparency a little less on the blue fountain, and let me make the gravitation force a little bit lower. So let's do this as 0.1 maybe here. And let me go down to where I'm creating the particles for the fountain, which is this guy. And let me make this a little bit more solid, make that 100 so you can see it a little better. So now we have this thing that's like a cool little fountain, maybe of sparks or of water or whatever you want to think of it as, spraying up and out. And then here's this guy making those things happen too. And maybe there's a little too much randomness to the speed on the yellow thing, but you can see gravity affecting those and pulling them downwards. Now there is one other thing that you might want to consider for optimization reasons, and that's once the particles leave the screen, they could be reclaimed too. Right now they still have a lifetime, but you could make it so that if their X and their Y values are such that they are off the screen, or X is off the screen or Y is off the screen, then we just go ahead and reclaim them. There's no reason to keep having them have a lifetime. Now that is true in this case, but if we had a 3D game where the camera could pan around, we don't want to have them disappear and then be gone when we rotate the camera. So you could do that or not, I suppose. But notice we have both of these effects here, the one kind of dripping down. And let me, just for fun, let me make that a little bit brighter yet. So let's do 200 on these. Now maybe you can see that a little bit better with that fountain happening. They're still slightly transparent, but not very much now. And it looks like a little kind of fountain. We could draw a little garden hose underneath there and have it like spraying. If we want to change the angle of that, let's point that a slightly different direction here. And that is the first particle system, this guy. So let's change the angle here from, let's make it like 45 degrees, or let's do 35 degrees to 55 degrees. Now you kind of have that spraying off at an angle like that. So you can imagine the end of a garden hose there, spraying that off. And if we wanted to, there's some other things we could do as well. Like, for example, the range of speeds at which those are coming out. If we wanted to make it a little more uniform, then here we could say, only give it a little bit of variance, 4 to 5. And now you notice the stream stays a little more uniform. Turn on the garden hose sprayer. All right, so very cool. And you can kind of see that effect there from that. And this one, when you press A, obviously still works as well. All right, so those now have gravity associated with them. So that's one of the last things I was going to do today. Well, I suppose I was going to make an emitter object from this. And to turn that into an emitter class, that turns out to be pretty easy as well. Oh, also I wanted to change the size and or color of the objects over time. And let me go ahead and do that quickly here. So if we want to change the size and or color over time, let's do that. Let's make something that looks like smoke. So let me make a third. Here, let me add let's do a save as. And on this save as, let me do particles 3. And let me make one that I tied to S for smoke. So let's do. Or actually, we're already at an hour and 4 minutes. But to make one that changes size, I'll just make one of those quickly. Maybe it won't be smoke, but we'll go ahead and do that quickly here. So let's do particle system 3. Let's copy the one we did here for the kind of spark things going in all directions. And let's make that one tied to the S key. And we'll make it the same, but we'll make this one kind of, rather than going all directions, we'll kind of make them go more in maybe the upward direction here. So let's do 0 to 180. And I'm going to make them go really slowly here. So 0.2 to 1.0. I'll give them a longer lifetime, like 400. And now here's where we're going to get into changing the size of them. Let's take a look at how that works first. Let me go ahead and add the things here to do that update. For particle system 3, we update them, we render them. And now up here, what I'm going to do is that we're going to go ahead and look at what those look like, but I'm going to change the color. I'm going to start these out as kind of a white color here. Like that. And that's tied to the S key. And you'll notice that those are being affected and kind of pulled downwards. And one of the changes that I want to make here is I want to make it so those particles, as they're created in here, that downward force actually has some sort of a way to change it. So some of the things can be affected by gravity, other ones are not going to be. So what I'm going to do is I'm going to make this dy plus equals 0.1. I'm going to take that. I'm going to make that a gravity. It's going to be self.gravity. And I'm going to just call it F underscore gravity for force of gravity. And up here, self.F underscore gravity equal. Now there it's going to say 0.1, but what I'm going to do is I'm going to create that up here as an optional parameter. That's going to be 0.1 by default. So if I don't provide it, it will be 0.1, which will make it work with all the code that I had before. But if I do provide it, it'll do that. Now what I'm going to do is down in my code that actually creates the particles for that third particle system, which is this one when we press S, I'm going to add that at the end of this list here, and I'm going to say F underscore gravity equal 0.0. So now the other ones will still work like they did. Oops, somehow I accidentally deleted that F underscore gravity. Okay, so now the other ones should still work like they did. There's the spray of that, there are those. But now when I press, I think I called that the right thing. Oh, I need to pass that through from my particle emit here. And pass that through here. Okay. So now the other one should work like they did before, but S, now notice, does not have that effective gravity like that one has. And the most particles are moving up much more slowly. And in fact, if we wanted to have them drift up and away, that would be relatively easy to do as well. Now, last thing I want to do with this, let's change the position of that one. Let's move that to the side of the other side of the screen here. So let's see, that's the third one. There's when we press S. Let's start it out at 500 or 600. Let's look at where that is. Okay, so S is over there. Space is in the middle. Yellow is over there. So there's all three of them kind of going at once. But now let's do something with that smoke one when we press S, where we make those particles larger so their size increases over time. And let's also make their color change over time. So to make the size increase over time, what we would do with those is as we update them, the thing that I want to do is essentially give them the ability to change their size as they get updated. And really what we ought to do is do inheritance, which is another whole lecture. But the idea for changing the size of any of these particles over time is every time we update them in here, we want them to get slightly larger. So I'm just going to add that. This will affect all of them for right now. So I'm going to do self.size. Let's do times equals 0.0 or 1.01. So they're going to get a little bit bigger every time they get drawn. And I don't know if you can tell that or not now, but you can see that these are actually larger now. Let's do the smoke one since those last longer. And now we have something that looks much more smoke-like. And it's kind of taking over. And you can see they'll eventually grow and then disappear. As they get reclaimed. And so I've let off the spacebar now, and you should see them all start to disappear now. But those are, the lifetime of those is going for quite a while, so they're getting very, very large. But it also works with these. Notice they're bigger the longer they're in existence. There I did just a few. Notice maybe that's a little bit out of control for the lifetime that they have. So we could either lower the lifetime or reduce the amount we're making larger. Add an extra 0 there, like that. Let's see what that does. But you can definitely see those things getting larger. Maybe that's not quite enough now, so let's add. Like that, maybe. But now let's make them so they get more transparent as their life progresses. So to do that, what we're going to do is we're going to change the color of these over time. So not only are we going to change the size every time they're updated, we're going to change the color. So what I'm going to do is I'm going to extract the parts of that. So red, green, blue, or red, green, blue, alpha, equal self.color. And now I'm going to modify them, and I'm going to say, for example, alpha equal or times equal 0.99. So it's going to get 1% smaller for every frame that happens. And now I'm going to say self.color equal RGBA. And maybe I reduce the green and the red and the green a little bit too. So maybe red times equals 0.99, green times equals 0.99. But we're going to leave the blue alone. And so we're taking the color out, modifying it a little bit, putting it back. And let's see what happens here. So here's the smoke. You'll notice that it starts out white and it goes toward, finishes with kind of a blue. And now you're starting to see something that's a little more of that organic effect that you can get from particle effects. So not only are those smoke particles getting bigger, but they're changing in color. And in fact, if we wanted to, we could start out the colors that are more, they start out more red, they move towards blue, some of it increases, some of it decreases. But notice that since we did this in the main particle class, it's going to affect all of them. So that starts out a little more whiter and finishes more blue. This one isn't affected quite as much because the red and green are fading out, but you can kind of see those fading out more toward that darker color. But the smoke actually looks pretty cool at that point, with those getting larger as the lifetime increases. And also notice that the alpha, it's fading them out. It's fading them out to non-existent. And that's where you really get that kind of nice kind of particle effect look to that. And you can see that organic kind of look to it there. So when you're playing a game and you're in 3D and the boots are hitting the ground and there's a little cloud of dust that's coming up around that, you can kind of see that at play here. Or as something falls in the water, a wave crashes and there's like a spray mist that comes out of that, or a campfire that's burning and there's smoke coming out of it. You can see that as well. All right, so I'll finish up there with the code that we're doing. let's take a quick look at the lab and then we'll be done. So let's switch over to here and let me pull that back up. All right, so let's take a quick look at the lab assignment sheet for lab 1. So here I'm going to pause for just a second and I'll come back once I have that loaded up. Okay, so to finish things up here, let's switch over and take a quick look at the lab sheet. All right, so here's the lab. This is Game Programming Foundations 2. There's a missing S up there in the title. But this is assignment 1, and this is dealing with objects, instances, and trigonometry, but they're going to be aspects of the particle effects that are going to come into play here and be useful for you to look at. So if we look at this, you're going to make a bomb object. It has a self X, self Y, a direction, speed, and fuse length. Fuse length is a lot like the lifetime that we were doing before, but that bomb itself is going to be moved around on the screen. So when you're going to essentially create bombs, they're going to fall toward the bottom and land on the bottom of the screen, and then they're going to blow up in a spray of particles. So you're going to create a shrapnel class, which itself is going to be like the object class. But then the main, and that's going to have those things there. But essentially the way your main program works is if you left click with the mouse, it creates a bomb on the screen at the mouse coordinates. The bomb will have a random initial speed and it'll be affected by gravity. So as you click your mouse, bombs will come flying out. They'll fall toward the bottom of the screen. They'll all be rendered on the screen. If the bomb's fuse gets to 0, you're going to take the bomb out of the bomb list and you're going to replace it with 50 shrapnel objects at the position where the bomb was before it got removed. So in other words, the bomb will tick down to 0 and then boom, and you'll see shrapnel blow out, kind of like the particle code we have here. You're also then going to move the shrapnel pieces. If their lifetime ever gets to be 0 or they leave the screen, then we're going to remove them from the screen. So it's similar to what we're doing here. The stuff we did in class today should help with that. One thing to note, the shrapnel, you probably want to draw that with a drawing command, pygame.gfxdraw.filledcircle. Probably makes a lot of sense for that. The bombs, though, if you read what it says to do with those, it says for the render for the bomb, it says use an image, draw the bomb with an image. So you'll have to refresh yourself on how to draw things using an image, pygame.image.load to load it. Once it's loaded, you're going to have to do a blit, this ds display surface.blit of whatever the image was that you loaded. And if you want, you could draw your own in Photoshop or GIMP or Paint.net or whatever. You can draw your own bomb as an image, or you can just do a Google image search for like cartoon bomb or whatever, and then make those be the image. But that's basically what the lab is supposed to do. Next class, I might quickly do something fun and add how would you make a fuse? So make a fuse that burns down before the thing blows up. I might just show you how to do the fuses. If you want to add that, then that's how you learn to program, is by playing with things and making things. And then we're going to have another class where we talk a little bit about inheritance in object-oriented programming. Other uses of trigonometry are coming up shortly as well. But for the rest of the day today and before next class, I want you to get started on this bomb lab. Given all the stuff we've done today, it shouldn't be overly difficult to get that stuff to work. So I'd encourage you to get started on that. It's very similar to the particle effect stuff that we did earlier today. And so that's it for today. Let me go back to the presentation for just a second here. What we learned today will help you. So you should probably take a look at that and try to code some of that yourself. I will post those 3 the example programs I did today. I'll post those to the course page in a zip file for you to look at to give you some help. And other than that, that's it. So work on your lab, stay safe, wear a mask if you're around other people that aren't part of your household, wash your hands regularly, and that's it for today.